All right. So um, splitting data sets in machine learning, it's kind of like, those magic tricks, right?
Right.
Like if the magician like revealed how the trick worked too soon,
Right, yeah.
it would kind of ruin the whole illusion.
Yeah, yeah. Yeah.
That's kind of what can happen if we don't split our data the right way.
It's all about like thinking about how this model we're building is going to work in the real world. Like it's almost like if you sent a robot out to do something, out on a mission or something,
Yeah.
and it didn't have the right training.
Oh, okay, yeah.
It would just be kind of like flailing around, wouldn't it?
So it's not enough to just kind of like train our model on like a big pile of data. We have to be more strategic.
Yeah,
Yeah.
yeah, you got it. Imagine like training a self-driving car, but only on days where it's sunny.
Okay.
So it might do great on its tests on those sunny days, but then you get some rain or some snow,
Right.
and it's totally confused.
Yeah.
That's where this idea of splitting comes in. It helps to avoid this problem that we call overfitting,
Okay.
where the model, it's like it gets really good at, like the data it's already seen,
Right.
but then anything new, it fails.
So we don't want it to just be like memorizing answers.
Okay.
We want it to like learn like how to generalize to new situations.
Exactly. That's a great way to put it. And that's why, typically what we do is we take our data and we split it into, we say 3 sets.
Okay.
There's the training set,
Right.
the validation set, and then the test set.
So the training set, that's kind of like the main course,
Yeah.
right? Like that's where it really like learns the ropes.
It's like, you give the model the textbook, it can just like absorb all this information. And then the validation set, that's kind of like a pop quiz,
Okay.
like throughout the semester.
Yeah.
And it lets us sort of like fine tune, how it's learning, adjust its parameters, but without actually letting it see the final exam.
Oh, so it's like we're like preventing our like overeager students
Exactly.
from like cramming for the wrong test.
Yeah. Don't want them to see those answers ahead of time.
And then, so the test set is like the real deal.
Exactly.
The final exam.
The final.
This is where we really see how it performs.
Yep. And this is a really crucial point. That test set, it has to be kept like locked away,
What?
until the very end.
Yeah.
We can't let our model sneak a peek. Otherwise,
Right.
it'll ace the test, but it won't have really understood the material.
So like, no answer key into the sleeve.
Exactly, yeah.
Now I've heard like, people throw around this like 70-20-10 split
Mm-hmm.
for these sets. Is that like a golden rule? Or does it really just depend?
Yeah, so that 70-20-10, that's a pretty good starting point, especially if you don't have a ton of data. But let's say you've got like a massive data set. I'm talking like millions of entries. You might be able to get away with having a smaller test set. But the important thing is to make sure that each set has enough data in it that it's actually statistically meaningful.
So it's a bit of a balancing act. You want enough for it to learn, but you also want enough to like really get a good assessment.
That's exactly right. It's all about balance. Now, have you ever heard of cross-validation? It's like a more advanced technique. It's sort of, imagine instead of just having one final exam at the end of the semester,
Right.
you have like multiple tests throughout the semester.
So that gives us like a more like well-rounded like sense of like the student's understanding.
Exactly. Exactly. Yeah, like instead of judging them just based on that one performance, you get a broader view.
Yeah.
And so one way we can do this is something called k-fold cross-validation. And that's where we like divide our data into, we call them A groups or folds. And then each of those folds, it gets a turn being the test set while all the other ones are used for training.
So it's kind of like we're testing the student on like different chapters of the textbook.
Yeah.
Just to make sure they haven't just like crammed for that one topic.
That's a great analogy. Yeah, we want to make sure that they have, a really good grasp of all of the material.
Yeah, okay. I'm starting to get it.
Yeah, sure.
So now that we've covered kind of like these basic splitting methods, are there times where we have to like twist things up a little bit? Like, are there scenarios where these like standard methods like maybe don't quite cut it?
That's a great question. And yeah, you're right on. There are definitely some cases where we need to get a little bit more creative. So let's think about that. Okay, so imagine this. We're dealing with a data set where like most of the data is one thing, but then there's this like tiny little sliver that's something else.
Okay.
Like, if you were trying to predict like fraudulent transactions.
Right. Okay.
Most of them are going to be fine.
Yeah.
But then every once in a while, there's that fraudulent one.
Yeah, that makes sense.
Yeah.
That could really mess things up.
Yeah, and if we just randomly split that data, our model, it might not even see enough of those fraudulent transactions during training.
Oh,
It'd be like, you're trying to teach someone to spot counterfeit money,
right.
but you only show them like 2 fake bills.
Right. They might get really good at spotting the real ones, but
Right.
they miss all those like little subtle cues.
Exactly.
Right.
So that's where this idea of stratified splitting comes in. And it's like, imagine, a student, they need to get a balanced curriculum, right? Like, they need to be exposed to all the different topics, even the ones that maybe don't come up as often.
Right. So we want to make sure both our training and our test sets have a good mix of both.
Exactly. You want them to reflect that real world distribution.
Got it.
Otherwise, you end up with a model that's biased.
Right, towards the majority class. Okay.
Yeah, and totally blind to those like subtle cues, those minority classes.
So now, what about like those time series data sets? Like the stock prices and stuff,
Oh, yeah. Those are tricky. Those can be really tricky.
where the order matters.
Yeah, because like imagine if you're trying to predict tomorrow's temperature
Right.
and you're using, data from the past week. It wouldn't be fair to give the model information about next week's temperatures, would it?
Yeah, that's like giving the student tomorrow's newspaper to help them with their history quiz.
Exactly. Like time travel, it's not allowed in this game.
Right.
So we can't just shuffle time series data. We got to respect that temporal order.
So the training data is always from the past.
Always from the past.
Test data from the future.
Yep.
Okay,
Yeah.
got it. So it's all about making sure our model learns from those historical trends.
Yeah.
And then we test it on its ability to predict what happens next without any unfair peaks.
Exactly. You got it. No peeking into the future. It's all about simulating the real world.
Yeah. Okay, I think I'm starting to get a good sense of these different splitting strategies. But even if we're doing everything right, are there still pitfalls that we need to be aware of? Are there common mistakes that people make?
Oh, yeah, for sure. Even the best of us, sometimes we fall into these traps.
Okay, like what?
Well, one of the most common ones is this thing called data leakage.
Data leakage.
Yeah, it's sneaky. It's like, you accidentally give the student the answers to the exam
Oh, okay.
before they take it.
How does that happen with data?
Sometimes it's subtle.
Yeah.
Let's say we're trying to predict customer churn. And we accidentally include, in our training data, we accidentally include information about what the customer did in the future. So it would be letting the student see who canceled their subscription next month, but we're trying to predict who's going to cancel this month.
Oh, okay. So it's it seems like it's performing really well.
Yeah, it gets this artificially inflated accuracy. It's cheating.
Right.
It had access to information that it shouldn't have had.
Okay.
So data leakage, it can be a real headache.
Right. So it's all about playing fair,
Yeah.
making sure the model is learning from the right stuff.
Exactly. You got to make sure it's a fair test. So are you ready for another pitfall?
Yeah, hit me.
All right. So another common one is people sometimes use a test set that's just too small.
Okay.
It's like, imagine you're trying to judge a chef's skills,
All right.
but you only try one bite of one dish.
Okay, yeah. They might have just nailed that dish, but
Yeah.
it doesn't tell us anything about the rest of their abilities.
Exactly. That tiny little test set, it might not actually be representative of, all the different kinds of data that are out there.
You could overestimate the model's performance.
Exactly. And then when it gets out in the real world,
Right.
it totally fails.
So it's like a balancing act. We want it big enough to really capture the range, but not so big that we're losing valuable training data.
Exactly. That's the sweet spot. Now, one more pitfall, reproducibility.
Reproducibility. I feel like I've heard that before, but I don't really know what that means in this context.
Okay, so think of it this way. Imagine you're trying to bake a cake, but you don't have a recipe.
Oh,
Right. You might get lucky once,
right.
but you're not going to be able to recreate that success. And it's the same with machine learning.
So it's about making sure that we can do it again and get the same result.
Exactly. Yeah, it's like having a recipe so you can bake the same cake twice.
Okay.
And in machine learning, we do this by setting what's called a random seed. And that ensures that when we split our data, if we run it again or someone else runs it again, they're going to get the same split.
So it's we're writing down all those measurements
Yeah, exactly.
in the recipe so anyone can follow it and get the same cake.
Exactly. That makes our results way more reliable, way more trustworthy. It's like this fundamental part of good science.
Yeah, yeah. It's all about that consistency.
Yeah.
All right, so this has been a really cool, like, dive into all these nuances.
Yeah.
I feel like, I came in as a complete novice, and now I'm like at least like a semi-informed apprentice.
That's great to hear. I'm glad you're finding it interesting. It can be really fascinating stuff.
Yeah, so we've talked a lot about like the technical stuff, but I'm curious, like, what does all this mean for like the big picture of machine learning? Like, where are we headed with all this data wrangling?
That's a really great question. Splitting data sets, it's not just about like making our models a little bit more accurate. It's about making them like more reliable, more trustworthy,
Right.
and ultimately more impactful. It's like we want to make sure that we're not just getting the right answers, but that we're getting answers that we can actually rely on, you know?
Yeah, yeah. Answers that like actually work in the real world.
Exactly. So like think about it, right? We're getting to this point where medical diagnoses, financial forecasts, even legal decisions,
Right.
they're all being informed by these machine learning models more and more.
That's exciting, but it's also a little bit scary, to be honest.
It is. It is. And that's why, getting this splitting thing right, it's more important than ever.
Yeah.
Because we want to make sure that these models they're built on solid foundations,
Right.
that they're not just like spitting out bias or misleading results.
So it's like we're making sure that the algorithms, like the things that are actually shaping our world,
yeah.
that they're built on, like fairness and accuracy.
Exactly. Exactly. And, as machine learning becomes more and more part of our lives, the way that we split our data, that's really going to have a huge impact.
So it's not just this like little technical detail. It's actually like a fundamental part
Yeah.
of making sure that machine learning is used responsibly and ethically.
I couldn't have said it better myself.
Yeah.
It's about making sure that these tools, which are so powerful,
Yeah.
that they're actually used to help people.
Right. Not like limit them or define them.
Exactly.
That's a really powerful thought. And it makes me think that like all this splitting stuff, it's really just one piece of this much bigger puzzle, right?
Yeah.
Like this whole quest to make sure that machine learning really works for everyone.
I think that's a really great way to put it. And it's a journey, It's not a destination. It's something that we're all in together. We need to collaborate, we need to be transparent, and we need to always be willing to learn and adapt.
Well, I think we've covered a ton of ground today.
We have.
From overfitting to cross-validation, stratified splitting, data leakage. I mean, we really got into the nitty-gritty
Yeah, we did.
of this whole like splitting thing.
And I really hope that everyone listening has like a better understanding now of how important this is.
Yeah, and I think, it's amazing how something that seems so technical can have such a big impact on like the future of this whole field.
Yeah, for sure. And who knows what's next? Machine learning is changing so fast.
Right.
The way we split our data, that's going to have to change too.
Well, on that note, I think it's time to wrap up this deep dive into the world of splitting data sets.
Yeah.
I want to thank you for coming on and sharing your expertise.
It's been a pleasure.
And to everyone listening out there, keep exploring, keep asking questions, and, keep pushing those boundaries of what's possible with machine learning. We'll see you next time.